All right, sorry about the break in videos. I had to go actually look up whether we were supposed to do the new new course description says we're doing the N1 PC hat and the N2 PC hat and the N2 QC hat. So we still have to check 4 of them, but we're using the pooled. So for a minute I was thinking we only had to check 2. I was wrong. All right, so what we're going to do is we're going to take the 1800 times the PC hat that we just calculated. And these are all going to come out bigger than 10, I can tell, but I'm going to show on my work just to be sure. And then we're going to do times the QC hat that we just calculated. And then we're also going to do N2, which is 3,000. And I really probably should have used the 1990 again. Oh well. Use the 3,000 times the 0.167 and times the 0.833. And all 4 of those have to come out greater than 10 because these are the expected counts of what would happen if they're all one big sample. Then we would expect to have gotten 300.6 people in 2005. And obviously this one's also going to come out bigger. And then we're going to do it again with 3,000. Do it again with 3,833. So yeah, you're supposed to check all 4 of those. Technically, you could check the 2 smaller ones, like just the P's and not the Q's, since P came out bigger, and that would be fine. This is definitely a yes. So that's the piece that changed the most so far, is that this gets done with the pooled counts. Really, I don't think they would mark you down if you did it with the actual counts, with the separated counts. It's just that's the most recent thing from the College Board, is that we're changing that policy. So that's why I'm a little awkward today, because I've never done it that way until they changed it. That's nice. Different than what it says in your textbook, by the way. Let's move on to do. The standard error is also going to change a little bit, because the standard error will also use the pooled. And I'll show you that as we get there. So that thing that we just did is useful for the normal condition, and it's also useful for the standard error, and that they've always been doing. It's funny how they just changed that one thing. We're still using Z. We're still doing something about a sample minus a population divided by a standard error, and the sample is now the P hats subtracted, 2005 minus P hat for 1990. That gets subtracting the population theoretical difference, which is 0, almost always. In fact, when you do the calculator shortcut, it assumes you're doing 0. And then on the bottom, we're going to do a pooled standard error. And I will show you how. It's almost like the regular standard error, except instead of doing P1 Q1 over N, we're going to do PC hat and QC hat over N1, which is N 2005. And then we're going to do the same thing with the other one, PC hat, QC hat over N2 1990. So you use the 2 sample sizes like usual, but we're going to pool and combine those p-values. I shouldn't call them p-values, the proportion values, because we're assuming it's all the same. So let's go there. We've got the 0.195 minus the 0.15, technically minus 0, but you could leave that off if you wanted to. Down here, we're not using either one of these. We're using the one that's combined. So the 167, 0.167 times 0.833 divided by my first sample size, which is 1800, and then do it again with the second sample size. There you go. That's a lot of work, isn't it? Did you know there's a calculated shortcut that will do all that? Of course there is. So you have permission if you want to type all of, or write this down or type it, whatever, and then not type it in your calculator, but just use the calculator shortcut. Let's look at that. Stat tests, same menu we usually go to, and this time it is 2 of something. It's a 2 sample t-test is what we're learning to do right now. That's another name for it. So we could, if we had data, you know what? It's not a t-test. I'm going back. So many mistakes today. 2 proportion t-test. We'll do 2 sample t-tests in lesson 10-2. The 2 proportion z-test is what I meant to choose. This is where we put our x's and n's. And we already found our x's, didn't we? We found the 351 and the 1800. That's my first population and my first sample. My second sample was 450 out of 3000. And then I need to say that I'm doing a greater than, and then I need to calculate. Now the good news is the calculator automatically pools for you. It automatically does this and you don't even have to tell it to do that, which is really nice. So my z came out to be 4.048, and I should write this down. It's called a 2 proportion z-test. And my p-value I could find by doing a normal CDF of this number and then 999, or I could use the p-value that it says right here. Now notice that 2.58 is actually an impossible p-value. So if you ignore this last part of the screen, you might be wondering, how could you have a probability that's 2.58? Something's wrong with that. Don't forget this e-5, really important piece. 2.58 times 10 to the negative 5th. Little scientific notation review. You should have learned this in probably middle school. Move the decimal 5 places that way. So it is 0.00000258, really, really small p-value, even though you might have originally thought it was really big. This is the correct p-value. So be careful about that. Notice, by the way, the calculator did find my p-hat, combined PC hat. They call it p-hat, so that's interesting. That's the 0.167 that we just calculated. So there's my z-score and my p-value that I'm supposed to find for the do step. And then we're going to conclude. Same pattern as we've always done. We're going to have our decision since p is super duper small. You could just say that if you wanted to, but I prefer to put the number. It is less than 0.05 by a lot. We reject the null hypothesis that, okay, what does it say? The null hypothesis says that the hearing loss is the same for both years. So I like to phrase this the same way we do with matched pairs, actually, that there is no difference. That's the null. No difference, nothing interesting happening here in the proportion of hearing loss in teens or teens with hearing loss, either way, between 2005 and 1990. So just a reminder, we have just rejected the null, which means we can conclude the alternate is true. You wouldn't want to use the word except here either, but it's okay to say we conclude that. So I like to add, actually, it's more and more important in the most recent rubrics that you add we conclude, or I conclude if you'd prefer, that teens in 2005 had more hearing loss than in 1990. And make sure you're writing about the populations. We wouldn't want to say the sample of teens had more hearing loss. We'd want to imply that it's the population of teens. Basically, hearing loss, this is evidence that it's worse in 2005 than it was in 1990. All right, take a deep breath. that is it for today. We will make the chart on the next during the next lesson. So second half of today, we'll make the chart.